Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good morning guys. Hi, how are you? So today we will look at 15.2 thermodynamic processes, where at the end of this chapter students should be able to define the following thermodynamic processes: isothermal, isovolumetric, isobaric and adiabatic. And then you need to sketch PV graph for all the processes. Okay, we have 4 common processes of thermodynamic. Okay, these 4 is isothermal, isovolumetric, isobaric and adiabatic. Okay, now we will look at a PV graph. Y-axis is P, pressure, and x-axis is V. And then we have 2 lines here. It is represent a temperature. 2 temperature with T1 and T2, where T2 is greater than T1. Okay, we will look at the first process, which is isobaric. Isobaric bar. Bar means pressure constant. So to have constant pressure graph, that means we will have a horizontal line. Okay, where initial to final, the pressure is constant with value P with different volume, V initial and V final. And then for second one, we have isochoric. Isochoric, or the other names is isovolumetric. It means constant volume. So constant volume means it can be downwards or upwards. The green line, initial and final, the volume is constant. And for the white line, it is isothermal. Isothermal means same temperature. So along white line, okay, overlap with the blue line, it is at the same temperature. So isothermal. So the last line is represent the adiabatic. Adiabatic, where it have change in pressure, volume, and also change in temperature. So when these 3 are changed, so that it is called as adiabatic, where adiabatic means Q is equals to 0. There is no change in heat. Okay. So now we will look at what is isothermal. It is defined as a process that occurs at constant temperature. In isothermal, delta U is equals to 0. Okay, why it is equals to 0? Because T1 is equals to T2, so that there is no change in temperature. So when we substitute the value, delta U will be equals to 0. So from fluid, that is delta U equals to Q minus W. Since it is equals to 0, we will get Q equals to W. So from the Boyle's law, since PV is constant, then P1 V1 equals to P2 V2. Okay, the second one here is isochoric or isovolumetric process. It is defined as a process that occurs at constant volume. And for isochoric, W will be equals to 0. Why? Because V1 is equals to V2. So the change in volume is equals to 0. When we substitute into the equation where W is equals to P delta V, we will get W equals to 0. So for fluid, delta U will be equals to W only. The third process is isobaric process. It is a process that occurs at constant pressure. From fluid, Q equals to delta U plus W. Then, since there is no change in pressure, the equation will remain the same, where delta U will be equals to Q minus P V2 minus V1. Okay. Alright, the last process is adiabatic process. It is defined as a process that occurs without the transfer of heat into or out of the system. So Q will be equals to 0. So from fluid equation, when substitute Q equals to 0, delta U will be equals to negative W. Okay, look at this graph, PV graph. Okay, for thermodynamic processes, we have 4 temperature here, where T4 greater than T3, greater than T2, and greater than T1. And then we have process AB, where it is lie on the same line blue, so it is a isothermal process. And we have pipe AC, there is a change in temperature, change in volume, and also change in pressure. So this one is adiabatic process, where Tc less than Ta. And then path A to D, it is a isochoric, where the volume is constant at Va. And then for path A to E, so A to E, it is a constant pressure, so we name it as isobaric. Okay, now we will look at example for subtopic 14.2. The question is, a gas system which undergoes an adiabatic process does 5 kJ of work against an external force. What is the change in its internal energy? A gas does work, so that W is negative 5 kJ. And then we need to find delta U. Adiabatic process means Q equals to W. So delta U equals to negative W from equation fluid. So substitute the value, we will get that W will be equals to positive 5000 joule or positive 5 kJ. Okay, now we will move to question number 2. A gas is compressed under constant pressure, so that it is a isobaric. Number 1, sketch the pressure volume graph. So we need to sketch PV graph. And number 2, how is the work done in compressing the gas? How is the work done in compressing the gas calculated? So W equals to what? And number 3, what will happen to the final temperature of the gas? So we sketch graph of PV. Okay, so constant pressure means horizontal line with the arrow to the left since it is compressing. Okay, number 2, W will be equals to P delta V, where VF minus VI. Since VF is less than VI, then we will get our W as negative value for compressed isobaric. Compressed isobaric or isobaric compression. Okay, so for the third one, what will happen to the final temperature of the gas? Okay, so for constant pressure or isobaric process, the PV graph, okay, straight line, where we will have two different volume, where V initial is greater than V final. And then other than that, the temperature initial also is not equals to temperature final, where T final is less than T initial. So from the triangle, this triangle, where PVT, since it is a constant pressure, we have V over T, where it is a isobaric process, or Boyle's law, V1 over T1 equals to V2 over T2, or V is directly proportional to temperature. So as V is decreasing, that means the final temperature also will be decreasing. Okay, this is the last example for the subtopic. A gas undergoes the following thermodynamic processes: isobaric expansion, heated at constant volume, compressed isothermally, and finally expand adiabatically back to its initial pressure and volume. Sketch all the processes given on the same PV graph. The first one is isobaric expansion. So we will sketch a horizontal line where the V final should be greater than V initial, since it is expand. Okay, and then heated at constant volume. So volume is constant and it is heating, so the arrow will be upwards at the constant volume V2. Compressed isothermally. So isothermal means same temperature. We will sketch a hyperbolic line, isothermally compressed. So the arrow will be to the left or upwards, to the left. And then adiabatically back to its initial pressure and volume. So the blue line represents the adiabatic process. So back to the initial at P1 and V1. Okay. So that's all for question 3. We will get a full mark if you write the unit 2. Okay, where the unit is pressure Pascal and volume is meter cube. Alright, this is the summary for chapter 14.2. Enjoy. Bye guys. Assalamualaikum.